Welcome to another introduction. In this video, we are going to talk about the JavaScript library Ramda JS. I'm here now at the documentation page of Ramda, but let's actually move to the GitHub repository because the Ramda page here is essentially just documentation. But here at the GitHub repository, we can find a short intro. So the question is, what is Ramda? Well, Ramda is, in their words, a practical functional library for JavaScript programmers. So in other words, it's another library that brings functional programming to JavaScript. And in my humble subjective opinion, this is an excellent library in comparison to some of the other libraries. So you might already be familiar with Ramda JS, but even if you're not, you're probably familiar with libraries such as Lodash or underscore. But Ramda does a few key things really right in terms of functional programming when compared to the libraries Lodash and underscore. There's actually this video called something along the lines of, hey underscore, you're doing it wrong. Now, of course, that was a long time ago, so it's entirely possible that Lodash and underscore have addressed these limitations. But anyways, Ramda is really excellent if you want to write functional programming in JavaScript. I mean, let's check out this text. They say, there are already several excellent libraries with functional flavors. Typically, they are meant to be general purpose toolkits suitable for working in multiple paradigms. Ramda, however, has a more focused goal. We wanted the library designed specifically for a functional programming style, one that makes it easy to create functional pipelines and one that never mutates user data. And this is really the key point. Ramda is really a functional library. But enough of this talk, let's actually get into this. So let's go back here to the documentation page. This is a piece of really excellent documentation. As you can see as I scroll down here, these are all the functions that the Ramda library exposes. And actually, if we go back here to the repository, you can go here into the source folder and you can see that we will have the source for each of these different functions. So if you start to wonder about how some particular function behaves, so let's search for map here and go to map, and you read this text and you read the definition and you read these examples, but you can't still really figure out what it does, or for some reason you want to understand what it does in more detail or how it's implemented, then you can go here to the source and find map here. We go to map.js, and here we have the implementation for that function. So some open source libraries, or digging through the code of some open source libraries, I can feel this fairly alienating. But actually, Ramda's source code is quite clean, maybe because also in some sense, the whole project is pretty simple because all of these different functions are self-contained. Either way, now I'm trailing off topic. You can search for you can search for the different functions here, or rather you can filter for the different functions, and these are essentially just listed here, and on this page we just have all of these functions with their definitions and some examples. There are a lot of them. And the key point here is that because we're doing functional programming, we can compose lots of different functions. So I figured the best way to dive into this is to look at some particular example. Now, I also considered actually going through all of these different functions and talking about what they do. If you think that sounds interesting, do let me know in the comments and I can make that as a future video. But as an introduction, let's just look at what we can do with Ramda rather than all of the things that we can do. So in my spare time, I've been working on a small project where I try to do a Monte Carlo simulation of different investment strategies, long-term investment strategies for cryptocurrency. And you'll get a video about that very soon, but I'm not yet finished. But anyways, I figured I would take an example from that realm so that it's not completely hypothetical, but it's actually something that I did some days ago. Not exactly like this, but my point is that the scenario is completely reasonable and is a scenario that you might actually find yourself in. So what we're going to do is that we're going to go over here to coinmarketcap.com. And if you're not familiar with cryptocurrencies or coinmarketcap.com, what they do is that they list the current prices and historical prices of different cryptocurrencies at different exchanges in the world. So what we are going to do is that we are going to take the historical prices of Bitcoin and the historical prices of Ethereum. We'll start with Bitcoin. So we'll go in here to Bitcoin and we'll go to historical data. And what I did, which you'll see in that other video when I get done with that simulation, is I essentially went here to all time and I just copied all the data. But what we are going to do now is that we are going to take just a portion of that data. So let's actually do it this way. Let's say last 7 days here. So we'll get exactly the last 7 days and I'll just copy this data. Now, where do I paste this data? Well, I've got this folder here. As you can see, it's completely empty. And let me just make a directory here, which we call input. And then let me make another directory, which we call source. So in source, I'll put the source code, and in input here, I'll put the input data. So we'll put this this market data that we have from CoinMarketCap. So I'll just start up Vim. I'll open a new file in this input folder, and I'll name this file btc.csv. Now, a CSV file is a comma separated value file. Essentially, it's a lightweight format that describes a table. So if we have a data file that also has headers, we would start with the headers. So let's say maybe we have animal, and then we have age. So maybe the first animal is a cat, and the age of that cat is 3 years. And then we have another cat which has an age of 4 years. And then we have a dog which has an age of 4 years also, and so forth and so forth and so forth. So essentially this could represent any data, but the point is that we separate columns using a comma, and we separate records using new lines, or rows using new lines. And clearly, you can probably see that the data that we copied here doesn't actually follow this CSV format, because we just copied this plain data that is space separated. And when I paste this data in, you can see that we don't have commas. Of course, we do actually have commas, but these commas separate something else. Here, the commas separate the month and day portion from the year within the date. And here, these commas are used to separate numbers, or not to separate different numbers, but to be separators within a number to make them easier to read. So when talking about CSV files, we can usually talk about CSV files even if they're not actually comma separated. They could, for example, be semicolon separated or space separated, and so forth. And what I did when I built this simulation is that I actually used Vim macros in order to manually sort of clean up this file and make it semicolon separated. But what I figured we would do now is that we would actually use Ramda, because if you think about it for a moment, just look at this portion here. Here we seem to have 2 spaces, but it's not actually 2 spaces. I actually think it's a tab, because you can see that I move kind of strangely here. So I'm not sure, we'll see what happens there. And here we have 1 space. So without thinking too much about this file, we'll try to sort this out in Ramda. But let me save this file, and then let me open another input file. So in the folder input, we'll create a new file called eth.csv. And again, so we're naming these CSV even though it's not actually comma separated. But I guess that's sort of the most sensible format I can come up with to call these files. But now we've created the eth file. We're back here at CoinMarketCap. Let me go back to the first page, and let's go into Ethereum, and then we will take the historical data from Ethereum, and again we'll take the same range, so we'll take the last 7 days. We'll essentially just plainly copy the data without thinking about it. We go back into the terminal, back into the file. I'll paste this data in, and again you can see it's not sort of neatly formatted, but we're not actually going to worry about that now. I'll save the file. I'll drop back into the terminal here, and let's think about this. So we have the input folder and we have the source folder. And now if I look what's inside the input folder, we have these 2 files. We have btc.csv and we have eth.csv. But of course, in this source folder, we don't have anything yet. So in the source folder, what we're going to do is that we're going to put our main JavaScript file, and then we're going to start to work with this data. But since we are going to use Ramda, we have to install Ramda. And in order to not install it globally, let me create an npm package here, or let me turn this into an npm package. So I'll just say npm init, and let's not worry about all this stuff. Apologies for that. Let me clear this. And now we have a package.json so that we can install packages. So let's say npm install, I'll save Ramda. That's finished, and we can now see that we have node modules, and in node modules we have Ramda. So supposedly we now have Ramda. So let's go back into Vim. Let's open the source folder and create a file called main.js. And I'll save this file, and in this file I'll essentially just do const r equals require Ramda. So we'll require Ramda and we'll put it in the variable r. And then let's just say console log hello world, just to see that we're all good and working. Then let me just map a keystroke to node, and then I'll run this file main.js, I think I called it. And you can see that our file runs fine, and it seems that we've successfully loaded Ramda. So let's actually check that out. So let's, instead of logging hello world, we'll log r. And you can see now that we get all of these functions, which are then functions from the Ramda library. So consider this, for example, zip width. So we'll go back here to the Ramda documentation, search for zip width, and you can see that zip width is a function that's exposed by the Ramda library. All good. Now let's actually do something useful. So what are we going to do? Well, what we are going to do is that we are going to create this pipeline. We're going to use the function pipe. So we're going to write some stuff here, a bunch of methods. We're going to pass a bunch of arguments to the pipe function. And then when we have this pipeline, what we're going to do is that we're going to pass an array of 2 arguments. And these 2 arguments are essentially the path to these 2 files that we've created. So it's input current folder / input / eth.csv, and as I wrote here, the btc.csv. So if I put this on one line, maybe it's more clear. So we're calling r.pipe, and what r.pipe does is that it accepts a bunch of functions here, and it composes in the reverse order, we'll get to this, it composes these functions together into a single function. And then we pass these 2 paths to that function that we've just created. And so essentially, think about functional programming. Data goes last. So this is our data, essentially. This is our data, and we've done, so in other words, we first specify what we want to do with that data. So let me just put console log here in that pipeline to hopefully make it a bit more clear. So if we run console log, well, we just get back this array, right? Because we say, I'll pass all of this stuff, sorry, I should say maybe all of this stuff, I'll pass this array through this pipeline, and the only thing that happens in this pipeline is a console log. So what happens is essentially we do console log, and then we pass all of this stuff, input, we pass this array, right? But let's move on. So we can now console log the data, but that's not super useful. What we first need to do is that we actually need to read these files. Now the problem with, let's search for read file node, and let's look at the documentation here. So we don't need to think about doing stuff asynchronously now. We can talk about that some other time. So let's just look for read file sync, right? And let's check out how this works. So what we do is that we call fs.readFileSync, and then we pass a path, and then we pass some options. The problem here is that we want to make use of something called currying. So we actually want to do this in the other order. We want to pass the options first and then pass the path. You'll see why in a moment. So let's construct our own function that we'll call read, maybe I'll just say readf, as a function that takes a path and then essentially just calls fs.readFile, and it reads the path, but then we pass the arguments. Let me just check out how this was. So we pass an options object, I assume, where we can say encoding, right? So we say encoding is, I guess it's UTF-8, something along those lines. So now if we call readf and then pass path, we will then load at this path using this particular encoding. The reason we do it this way is that we want to add the read file here to this pipeline, and we have to do it without specifying the data, right? It would not be a problem if we had the data. If we had the data, we could say read file, and then we just say, I mean, the path to the file. But we can't do that now because, again, we're doing functional programming, so the data comes last. So we're specifying what happens, and then we sort of push in the data. So we have to specify what the function does before it knows about the data. It's kind of a strange way of saying it, but hopefully you're following along. But the thing is, we can't just say readf, right? Because here we're passing an array, and this array consists of 2 paths. So we want to read 2 files, which is why we would say r.map readf. So now we're actually having a pipeline, right? The first argument to pipe is that we're saying map the function readf, and then we say console log. Let's just look at what this gives. Fs, I didn't load fs, so let's just say fs is require fs. Okay, so we get, we get undefined and undefined because I said we were going to call the synchronous version of the read file function, but of course I accidentally called the asynchronous version. So let's say read file sync. Right. And this looks like a bunch of gibberish, but if you look here, you can see that here's where our array starts, that's where it ends, and this is the first element, and this is the second element. So actually, the first one here is the BTC data, and the second one here is all of that ETH data. So that's fine and dandy. And now you can see that our previous suspicion was correct. You can see that we have these \t's. So actually it's not a comma separated file, it's a tab separated file, it seems. You can see we have these /t's or \t's, and we have these \n's. So hopefully that's consistent. So the tabs would be separating the columns, and the \n's would be separating the rows. But let's assume that, and let's move on. So what do we want to do next? Okay, so now we have the files, but then we want to go through both of these files, and we want to start to structure them. So how are we going to structure this? Well, we first need to separate all of the different columns, right? All the different columns and the rows. So let's start with the rows, actually. So we said the rows are probably constructed or separated by \n. That's what I said, right? Yeah, \n. So we need to split these strings by \n. I think that should probably be enough. Let's try this out. So what if we map, and then we say r.split on \n. And let me show you that we're now using these methods from Ramda. So split is a function here that first takes some character, then takes some value, and splits this string that we were given here using this values or by this value. So you can see we get an array back here where it's split by these dots. So A becomes its own element here, and B becomes its own element here, and so forth. And think about the notion of currying here. This is possible because every function in Ramda is curried. So that means that you can call it, you can partially apply the function. You can call it with only its first argument and then get back a function that accepts the second argument. And this is why this whole piping works, because we're saying map wants a function and it wants some data, but we're actually only giving it the function. And then when we get the data through this pipeline, map will be called with that data, and we will map over that data. Similarly, r.split here is only the function, or returns a function that accepts the second argument, which is the string that it's going to split, essentially. And that thing is going to be given by the map. Right, so to this map we're giving this whole array, and then map, of course, maps a function over every item in that array, and that function is the function returned by r.split. So r.split returns a function, and this function is applied with first this argument and then with this second argument. Okay, so let's look at what this gives us. So if we run this now, you can see that suddenly our data is a bit more structured. We now have this original array, this array of the two files, but instead of having the raw contents, we now have an original array containing two arrays. So this first array is an array of all of the rows from the BTC file, and the second array is an array of all of the rows from the ETH file. And this is actually starting to look like something now. So you can see that we've successfully separated all of the rows, and without looking too carefully at this, it seems that we've sort of successfully done that, except of course that we have this extra element in the end. So let's begin by removing this extra element to not cause ourselves any more issues. So this is actually very simple to do, because we just do another map, and then we just say drop last or something like that. Let's look at the documentation to make sure that we're right. Drop last returns a list containing all but the last n elements of a given list. Okay, so we also need to pass an n, right? So remember, partial application here. Drop last, and then we pass the number of items we want to drop, and then we pass the list. And the list will be passed automatically because we're in this pipeline. Okay, so we say drop last, and then we pass 1 because we only want to drop one item. Let's look at it now, right? This is before, this is what we have now. Before we had this extra empty element here, extra empty element here, but now we don't. Now we just end with some actual data here, and we end with some actual data here. Super good. Okay, let's move on. Next step is to replace these \t's, these tabs essentially, or not to replace them, but rather to split by them, because now we want to split them so that we have each of these different values in its own cell, right? We want to have an array of the two files, and then we want to have an array as every item representing all of the different rows. But in every row, we want to have an array that represents all of the different columns. So let's do another split, right? So after this drop last, we just do r.split. And by the way, we could optimize this, because you see that we're now repeating r.map. So I'm doing this for the sake of readability, but what we could do is that we could say r.map and then r.pipe and create another pipeline and then do all of these things without remapping, right? So we could do readf and then we do r.split, backslash, etc., etc. So we do the things that we're doing now without repeating the mapping. And this is actually much more efficient because we're not reiterating over the list multiple times. We might do that in the end, but for now, let's just stick to this for the sake of clarity. So what we do is that we split again, but this time we split on tabs, so on /t's, and then a comma, and then console log, and then let's go. So this didn't work. Let's look at what's going on here. Blah 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 does not have a method named split. Okay. So the problem now is that I forgot that we now have an array in an array. So we can't just say r.map, because when we say r.map, let me comment this line out, go back here, run again, right? If you look at this, we now not only have, we not only have an array, we have an array of arrays, which means that we don't have a string here, which means that we can't split here. So we need to map over this first array and then map over the second array, and then we have a string that can be split. So sorry, I forgot that. What we need to do, let's get this back in, is we need to say r.map again. So if you think about it, you can read it this way. We're saying pipe through all of this data, map over both of these files and read them. Map over both of these read file contents and split them into rows so that we have arrays. And then map over these two files that are now split into rows and drop the last row. But then map over these split files and map over every row and split every row into multiple columns. So let's look at what this looks like. Now this actually works, right? Suddenly, we have a lot more structure, right? Because we have an array of an array of an array, right? But the first array is because we have two files. The second array is because we have a bunch of rows. And then the third array is because we have a number of columns. Now, the thing is that let's simplify this. If we go back to the data here on CoinMarketCap, we're actually only interested in the price. And of course, we're interested in the asset. So we want to be able to separate the two assets from each other. But let's start with the price. So I'm just going to randomly choose the open price. I mean, we could choose the high or the low or the close, or we could aggregate them and sort of make some average or something, but we're just going to take the open price. So let's keep the date and let's keep the open price. So that means we only want the two first columns. And conveniently in Ramda, there's actually a function called the take. And if you look at take, it says returns the first n elements of the given list, blah, 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 blah. So if we say r.take1 from this array of foo_bar_baz, we'll get an array of foo. And this is exactly our scenario, right? We have an array of all of this data, of all of these different columns, but we don't actually want all of this stuff. We just want the date and we want the open price. I chose the open price clearly because this would be more convenient. So we want to take two items. So what we do, let's go back to the code, let's go back in here, and then let's say r.map, and we'll say r.take, and we'll take two. Close all of these parentheses, and let me run this again. And now you can see it's starting to look really simple, because now we have this outer array of files, and then the first file, and then the second file. And in each of these files, we have a bunch of rows. And within each row, we have a bunch of columns, but now we only have two columns, which is the columns that we actually want. So I just realized that actually we are also interested in the name. I mean, we need to be able to separate the BTC data from the ETH data. So somehow we need to identify this as the BTC data and this as the ETH data. And the most simple way to do this is probably to replace this array here, right? So we're calling this using an array. And what we should probably do is that we should change this array into an object, right? And the key here would be BTC, and the key here would be ETH. Something along these lines, right? That would probably make it easier to here not just use map, but we could, instead of using map, we could use this map object indexed. So in other words, it's a map that is aware of the key that it's currently mapping over. And by the way, I mean, that's another awesome part about Ramda. You can map not only over arrays, but you can also map over objects. But again, the point here is that if we use that approach, we need to map in a way that's also knows about the keys, because we want to be able to use these keys as well. But actually, let's continue on the path that we're on now. Let's hack our way into a solution, right? So let's say that we have this array and we don't have these keys, and somehow we need to extract the data from the name, the word BTC here and the word ETH here. So how would we do that? Well, we need to do something else with the readf here, the read file function. So think about it. Now we're not only interested in just mapping, now we're not only interested in just reading the file. What we want to do is that we want to read the file, and we also want to prepend a string that contains this word, whether it's BTC or whether it's ETH. So we need to extract that from the file name, or from the file path, I should say, and then we need to prepend that to the string that we're reading. So let's try to figure out. This might be a bit tricky. So let me write another function that we call readf. And let's actually comment this out for the moment, right? So this function takes a path just as the other one, but we're going to make this another Ramda function. So this is another Ramda pipeline, and to this pipeline we of course pass the path. And of course, when you have something that looks like this, what you've got is a function that takes an argument path, constructs a function using Ramda, and then passes that only argument to this Ramda function. So here we can make this a pointer-free function. We can actually remove this call here and just say that readf is a function that is essentially returned by this pipeline. So this pipeline will expect one argument, and that argument will be the file. So we don't actually need to have the file like that. So actually, I'm realizing we actually need both of these, right? We still need to be able to read. So let's just call this read file sync, and let's call this read data. I mean, these are silly names. I apologize. We should refactor this some other time, but let's not think about that now. So what we do in this pipeline, this might look a bit odd, but I think we're going to be able to solve it like this. There's a function called converge, which essentially says that you can add some function here, and then you can add an array of some number of functions. So let's say f1 and f2. So what happens is that we run f1 with the data that's passed into the pipeline, and then we run f2 with the data that's passed into the pipeline separately, right? These have nothing to do with each other. But then we take the result of running these two functions and pass them to this original function f. So that's why it's called converge, because you run a number of functions with your data as input, and then you pass all of those sequentially as arguments to this particular function that you use in order to converge all of this data into a single value. So what I want to use as converge here is essentially some kind of either a concat or some add, right? I think it's probably concat. So what we're trying to do is that f1 here should be extract BTC or ETH from the name of the file, or essentially from the path, right? And then the function number 2 should read the file contents, right? And then we prepend this value to this value. So let's see if we have some kind of suitable function. I guess it would be concat. So concat, yeah, can take a string and then a string and then concatenates them into a single string. And again, you can see Ramda is super flexible. You can also give it an array and it concates the two arrays. But let's try this. I think this might work out. So let's just make this simple. Here we'll add an anonymous function that simply returns foo temporarily. Just so we don't have to think about that function now. And here, this one we know, because here we can just say read file sync, and we don't actually have to say anything else, right? Because then that will be passed with the data that's passed to read data. So now, in order to think about one problem at a time, let me comment out this stuff. So we only have this original map, so that we read both of the two files. And now, sorry, this should not be readf, this should be read data. And then we just console logs. Let's try this out to see where we're at. Unexpected token, parenthesis after converge. Oh, sorry, that was extremely silly. I forgot to add the converge function, which is r.concat. So that's our converging function. And actually, what do you know? This actually worked. You can see that now that we've prepended foo and then we have all of this data. And now we should immediately realize that, of course, we need to actually prepend this tab as well, so we can treat it the same way. So we'll prepend foo and /t, and of course, sorry, it shouldn't be foo, but let's look at that again. Then we have foo, some delimiter, and then the actual data. So that works fine. Now we just need to figure out this function. So how do we do that? Well, let's put our identity. So the identity function is essentially just a function that looks like this. When passed an x, it returns x. That's it. So the reason we do that is I just want to have a look at this data, right? Of course, I mean, we can see it here, but I'm just showing this because sometimes you sort of forget where you're at, and then it's useful to sort of print identity to see what you're working with. So this is the stuff that we're working with. And essentially we want to extract this portion. So let's think about it. How about, so a regex here is probably suitable, or it's something like splitting by slash. Yeah, I mean, since these are super simple, let's actually just do this. Yeah, but let's think about it. Can we do this with a regex? We want to match a slash followed by, actually, let's make it, let's make a sort of kind of ugly regex and just say, let's match a slash. No, but then we need a capture. I was going to say let's match a slash, 3 characters, and then a dot. But then we need to remove these things. So actually, I think it's more. I mean, if I did this properly, I would think about this a while and do a proper regex that actually just tightly gets the value that we want. But now, in order to save everyone's time, let's just make a quick pipe here where we say, okay, let's split by, what was it? We split by /. So we split by /, and then we've got, yeah, so let me add a new line here to make it a bit more readable. So we split by /, and then we would split by, let's say, dot, right? R dot split on a dot, sorry. And then what? We split by dot. That means, yeah, this is really stupid. Let's not actually do that. So let's look at replace here. Replace probably takes a regex, right? So replace takes a regex. So we could do it this way. That would also be very simple. We could replace greedily everything up to a, so let's remove these two and let's just say r.replace, and we replace everything up to any number of characters up to a literal dot, and then we end that regex. What did I do wrong? Yeah, let's trial and error these regexes so we don't have to Google. So what I want to say is any number of characters followed by a literal dot, but I'm guessing the literal would be like this, and we want to replace that with the empty string. So let's just look at what we get when we do that. That's not at all what we were intending. Oh, sorry, now we have identity here. So yeah, so then we didn't actually replace anything. So what's the problem here? Let's say replace everything like this. That's so let's just say star. Yeah, we didn't replace anything. What's going on here? Because I can't just say star. Oh, sorry, star is repetition. Dot is of course any character. So let's make this global. So let's say let's remove any character, any consecutive characters, right? So now we've removed the whole string. We previously had that. Now we have nothing because we've removed all of the characters. But what we want to do is we want to remove all characters up to a literal dot. No, sorry, it's up to a literal slash. Yep, up to a literal /. Yeah, and then we get btc.csv and we get eth.csv. And then we do another replace. So sorry, I was totally confused about the regexes first. So anyways, so in the second regex, what do? Well, we want to, now we have eth.csv, and then we just want to remove from the dot to the end, right? So a literal dot followed by any number of characters we replace with nothing. So that didn't work out. A literal dot, sorry, again, I keep saying star. A literal dot followed by any character all the way to the end. And then we have eth, and then we have btc. So sorry. And yeah, you could probably figure out a way to merge these into a single regex, but let's not think about that now. And then let's also add, so let's say it's append, we append the tab character in the end. Let's look at that. That didn't work out. So what is it called? Append? So maybe append only works on arrays, append, turns a new list containing the contents of the given list followed by the given element. Yeah, so append works on lists. So is it, I mean, maybe we have to use concat again, but then concat takes a string and a string. Yeah, because I'm worried about the order here. Prepend also takes only lists. But yeah, because my concern is that if we do concat r.concat and we want to concat with, we can flip the order here. So Ramda has this function where if you are not satisfied with the order of concat, right? Because think about it, concat says string number 1 and string number 2, and then it sort of appends string number 2 to string number 1. But we actually want to, we know this string, and we want to put that in the end. So we kind of have to do it in the other order. So you can use this very useful, let me see if they show it somewhere here, r.__, right? It's written under the curry section. So there's a special placeholder value, r.__, that may be used to specify gaps, allowing partial application of any combination of arguments regardless of their position. So usually if you don't think about that, you can only sort of partially apply the arguments up to the last argument, but sometimes, or up to the last argument, but sometimes you want to partially apply some other argument, which is exactly what we want to do in this case. So we want to say the first one I don't know, right? r.__, but I know the second one, and that's essentially this thing, /t. And probably I'm confused here and I'm in a rush, so I'm trying to figure out a way that isn't really elegant, and we can probably figure out a different way to do this. Anyways, let's look at what happens if we do that. So that actually works. So then we have btc/t and we have eth/t. Pretty cool. Pretty cool. So read data works, read file sync works, and now we can reintroduce this stuff that we had before. And if we do that and then run, you can see that that still works because it was working on arrays. And what we did is just that we added another element using the same sort of structure of that array as we had of the original data. Or sorry, I mean, we prepended another string to this long string that was the file. So we added another string into the file that followed the same structure of that original file. So now you can see that we have eth here and we have btc here. But actually, this was pretty stupid of me. Now you can see that we have a humongous problem because BTC was of course only added to the first row. So now I'm realizing maybe this was a catastrophically bad idea. Because I thought the only thing we would have to do now was to increase this 2 when we take 2 elements to 3. But actually that's not it, because BTC, we only have that on the first line. I should have thought this one through. So what I'm going to do is I'm going to do this. So we're going to introduce a header line and make this eth and BTC part of that header line. So you remember I talked about headers in CSV in the beginning. So instead of doing something like, so concat here is our convergence function, but we are ending with a tab. But if we instead end on a \n, I think \n was used for new lines, right? Let's look at this old data here. Right, \n was used for new lines. So if we end on \n, and let me comment this stuff out again so we're looking at the actual file contents, then you can see that we're ending on a \n here, which means that we have another initial column here. So if you look at what happens if we sort of parse that data using our old function, we have a column here, a first sort of header column that says BTC and a first header column that says ETH. But now let's actually add some more data to that, right? So instead of just having ETH and BTC, let's add actual columns. So let's say, so here we first have date, then we have price, right? And then this third value was accidental because again, I was trying to switch this from 2 to 3 in order because I thought that was the only change necessary. But let's switch this back to 2 and let's look at the data. And now we only have the date and then price. But instead of saying price, let's say the name of the asset. So how do we do that? Well, instead of just adding \n, we need another thing. So first, I guess we need another concat here. So we'll start with another concat, and what we concat is the name of the first column, which is essentially date, right? So we'll add that first. Let's look at that. And then we have date BTC, but of course we need the delimiter as well, so that we'll split on that. So now we have date for the first column, and then we have BTC for the second column. So that was actually all that we needed, right? So this just has strange tabbing, but if you think about it, date here is the header of this column, and BTC of the first column essentially, and BTC here is the header of the second column. So that's pretty sensible actually. So now we're back, finally, we're back into a sensible place. Now we can start to think about this, this second pipeline that we have here. Okay, so what's the next target? Well, it was a bit silly that we added this date string, because what I think we should target is that I actually think we should remove this date, because I mean they are ordered, and well, I mean for the scenario that I use this data, I didn't actually care about the date, I just cared about them being in the correct order. So what I think we should target is that instead of having an array of an array of an array, we should have an array of an array of an object, or rather of objects. So in other words, now we have an array that represents each row, where each of the items in that array corresponds to different columns or different cells, because we're already in a row. Well, what I want instead is that I want that this should be an object where the key of that object is BTC, and then the value that BTC points to is the price. The reason we want this is that we want to merge days, right? Now we have one whole array for all of the days of BTC, and one whole array of all of the days for Ether, or for ETH. So this is a bit tricky to handle in the scenario that I wanted to use it outside of this context. So what we're going to do is we're going to mash them, right? So we want to have pairs where we have a single object for, let's say, January 18th, 2018, where BTC points to this price and ETH points to this price. So it's an object of both of these. But we have to take this in step by step. So I think the easiest thing would just be to replace each of these rows with essentially an object where you have BTC pointing towards this particular price. So let's think about it. How are we going to get to that? So probably I think converge is going to help us here as well, because if we think about it, or actually let's start very simply. Let's remove the date first, because that's probably the simplest thing. So instead of taking 2, now we want to keep the first, or keep the second one, and then drop everything else. So I don't think there's actually anything called keep here, right? And maybe there is something like index. Prop goes by properties, right? So it doesn't go by, but actually there is index, right? Index by index of, find index. Yeah, we could lens it, right? So actually we could lens it. So we could say view, and then we take an index lens and take that index, and that would give us this value and this value. There is probably a simpler way to do it, but I failed to realize how that's done. But anyways, let's do it the lens way. So if we use lenses, instead of doing this, I mean, clearly we could of course just take 2 and then drop the first, and then that would also get us to where we want to go. But let's continue like this now. We could say r.map and then r.map, and then we do an r.view, which is essentially that we make use of a lens, and the lens that we want to use is, I think it's called lens index. Let's look at it. Yeah, lens index, and the index that we want is index 1, because again, if you look at the data, 0 is the date and 1 is the actual price. Same here. So we create a lens index at index 1, and I think actually that's it, right? Let's look at that. Yeah, actually that worked, right? So we lens, and by the way, lenses, super interesting concept. I highly recommend that you dig into that. And lenses in Ramda, I would say especially, is a very good introduction to lenses if you are familiar with JavaScript before. I mean, they're not actually that strange when you get the hang of them. And it's actually very interesting to look at how lenses are constructed, but that's a totally different story. But let me know if you want to talk about how to use lenses in Ramda, and we can talk about that in a specific video. But let's get back to this. So with lenses, we've now solved that problem. And now we have an array of these 2 files, where each of the files is essentially a bunch of rows, but the header of that array, think about head and tail, right? The head is the identifier for this particular object, or for what we want to turn into a number of rows of objects. So let's think about this. How are we going to do this? What we want is essentially that we want each of these rows to be an object where we use BTC as the key for that object. So we probably want to converge somehow, but I need to figure out how we're going to converge. So maybe we converge using some kind of map. No, that doesn't work. And so the tricky part, or the thing that throws me off, is that we only have a single occurrence of BTC here. So I mean, we could repeat and then zip and then make objects. but that just feels a bit silly and overly complicated. There should be an easier solution. And another alternative is just to turn BTC into the key, so to turn this into an object where BTC is the key, and then we have an array of all of these values or all of these prices. But I'm not sure how that necessarily helps us further on. So I think, I'm just thinking it should be possible to do this in a more simple manner. So the function we want to use is essentially that Ramda has this function called obj_of, right? Where we say r.obj_of must, and then we pass something, or sorry, must was an example here of a string. So you pass obj_of, and then you pass a string, and then you pass some kind of thing, and then it constructs an object where that string is the key, and the thing that you passed as the second argument becomes essentially the value for that's put under that key. So what we want here is, of course, that we want to turn this into the key. And again, it would be trivial to just say that it's an obj_of where we take head and then where we take tail. So then we could converge where head is the first function that we run and tail is the second function that we run, and we converge using obj_of. But again, that's not exactly what we want. Let's think about if we can solve this. So I'm getting pretty confused here, but I'm starting to think that maybe the map thing that we talked about might actually work, because when we converge, if you think about it, we could map. When we converge, we pass consecutive arguments, or we pass arguments one by one to this convergence function. If this convergence function is a map function that first takes something that says object_of and then takes an array of all of the values that we want to map over, then this should probably give us what we want. So let's try this. Let's at least see if this works. So let's say that we converge using map, right? And it's possible that we have to do something more here that I can't really think about, or I can't really think of at this moment. And then what we want to do is that we want to create this pipeline here where we somehow want to make use of r.head. We want to make use of the head. Let me show you why. Because here we want to extract this, and this is the head element, and this is the tail element, and this is the head, and this is the tail. So we want to somehow make use of the head, and then in the second argument we want to somehow make use of tail. So let's look at the head and tail function. So head, we just say r.head, and we get the first element from this array. So here we get phi. And tail, let's look at that. It's just called tail. And if we have 1, 2, 3, we get 2, 3, right? So this is actually exactly what we want. So let's start here in the second one. Here we just say r.tail, and that should be it, right? When we converge and we pass each of these consecutive or this array of things, and actually now I realize we need a map here. Sorry, that's my bad. We need to map and then pass this convergence function. So we pass the tail, okay? But what's the function here that we produce, right? Think about how map works. Map takes a function and then takes a data structure to map over. So we've successfully constructed the data structure, that we know, but here we need to construct a function, and this thing essentially just needs to be r.obj_of, right? We need to say create an object with the key, and this key is constructed by taking the head of the current list that you have. And then of course obj_of will expect the second argument, and that will be each consecutive item in this list of items. So I think this might work. Let's try this. Of course it doesn't work. So let's say fn is not a function, and I assume this is because we didn't produce a function here. So let's just say r.identity here. Again, just to keep this thing simple, to see where we're messing up. So if we say identity, okay, this doesn't work either. So we converge using map. Let's look at converge, right? Converge says, okay, you pass a function and then you pass an array of things, or an array of functions that you want to apply your data to. And this function doesn't ever get the data, but just gets these two items, or these two, the results of these two functions as arguments, right? And divide, let's look at divide. Divide, yeah, takes two separate arguments. So that's similar to what we want to do, right? If you look at map takes first a function and then a data structure. So I'm a bit confused about why this didn't work. So we're saying identity and then tail. Let's keep this simple. Let's remove this stuff for a moment, and let's just say r.map x foo. Right? I'm just trying to figure out where I'm messing up. So then we get foo, right? So maybe I need to double map because, wait, we're not, whoa, the first map is the file and then we have all of the rows. That's correct, right? So if we just look at the data we have, this is, oh sorry, now I forgot to say, this is the data that we have. We have an array and then we want to map over this array using converge. So, we do want to map, we do want to say converge, we do want to say map here, and then we want to have a bunch of functions. So identity is a function. Sorry, here's the problem. This doesn't yield a function. I mean, yeah, so this would be an x that we pass to identity, and that would be a function. So this might not actually work. Yeah, sorry. So like that, right? That works, yeah. So what am I doing wrong here? When we say r.obj of and then pass r.head, what is that going to give us? I mean, we then apply our data here, and obj of, the problem is of course that obj of, so or I mean at least that's a problem, or let's say key here, right? So obj of will be applied with our data. So again, let's do this. So that works, but I can't do head of data. This feels like I'm messing something up. That works, but why didn't it work the way I did it originally? Yeah, I'm sorry, I'm constructing my pipeline incorrectly. We want to pipe r.head and then r.obj of. This might actually be what we want. Yeah, that's what we want. So sorry, I did this incorrectly here because I was completely mistaken. I was passing the head function to obj of, but the problem is of course that r.head will here not ever be applied with the actual data that we have. So this is why we need to use pipe again, because we're composing a new function. We're constructing a function that is the composition of the head function and the object of. So what happens is that the data will first be passed through head and then passed. And then when we have the head, the head will be passed through object of, and then we'll thus say that now we're waiting for some data that we will create an object of, where the key will be essentially what we got from head here, and the head will of course be, yeah, now I'm in this new data, will be either BTC or ETH. And now we get to where we actually exactly where we want. So let's decide on a new goal. What's the next goal? Well, remember what I said. We now have this array here representing all the days of the BTC data, and we have an array here representing all the days of the Ether data. And we want to somehow merge these or zip these together where this is essentially 1 day and this is 1 day, and then this is 1 day and this is the second day. Or I mean, we pair them up. I think this might actually be what is known as a transpose. So let's look into that. Okay, so let's look at transpose here. Transpose says that, okay, if you have an array of arrays of A's and you want to produce another arrays of A's, you might be looking for transpose. But here's the thing, right? So let's look at this example. If you have this array that contains 3 arrays that each have 2 elements, then if you run transpose on that, you'll instead construct 2 arrays that each have 3 elements, right? So look at what happens here. We take 1 from here, we take 2 from here, and we take 3 from here, and that constitutes our first array. So in other words, we take the first element from the first array, the first element from the second array, and the first element from the third array, and that constitutes our first array, right? So we take the first element from all of our arrays, and that's the first array of the resulting array. And then we take the second element from all of our arrays, and that constitutes the second array of our output array. And I think this is actually exactly what we want. Let's look at our example again, right? So we have an array, we have an array of 2 arrays where each array has 1, 2, 3, 4, 5, 6 items. Actually, didn't we download 7 days? Let's think about that some other time. But I think we downloaded 7 days right now. I'm super confused. Anyways, 1, 2, 3, 4, 5, 6, yeah, whatever. So we have these 7 days. So we have 2 arrays with 7 elements, right? And they have 3 arrays of 2 elements, and instead produce 2 arrays with 3 elements, right? I mean, that's exactly our scenario. We have 2 arrays with 6 elements, and we want to produce 6 arrays with 2 elements. So actually it's exactly transposed. So probably, or I should say hopefully, what we can do is just, we can say r.map, actually not r.map. Probably now we just have to say transpose, right? Let's look at what this gives us. Bada bam, exactly what we want. We now have an array of arrays where each array is a single day containing the price of Bitcoin at that day and the price of Ethereum at that day. Now, of course, granted, this doesn't look superb because we have an array of 2 objects, but clearly we can now just merge these 2 objects, and that's why we created 2 keys. So I think what we're looking for here is merge all. Let's look at merge all. So merge all says merges a list of objects together into one object, right? So if you have an array of objects with the different keys, and then you say merge, yeah, then you get these into a single object instead of an array of multiple objects. And they are saying see also reduce, because I assume this would be the same thing as saying reduce, where your reduction function or your reducer function is merge. But let's just use merge all, right? So hopefully we can then just say r dot, can we just say merge all, or do we have to say map? Yeah, we have to map, right? Because we want to map. We don't want to merge everything, right? We want to merge on a day-to-day basis. So we say r.map, what was the name of the function? Merge all, right? Let's look at that. That gives us what we want. We now have an array of days where each day contains the price of Bitcoin and contains the price of Ethereum. So I should have set out this goal from the beginning, but in my mind, this was the end goal that I was thinking of. And now, of course, I mean, hopefully you can see that we've now, let me remove this comment, that's a bit silly. So you can see that with not a lot of code, and yeah, I mean, this is maybe not super obvious what's going on, but you could introduce a bunch of names and sort of organize this code in a way that makes it more clear what's going on if your code has to be read by somebody who's not intimately familiar with functional programming, or if you just want to make it more readable. But anyways, hopefully you can see how we can, with very little code, construct a lot of interesting things. So hopefully you can see now how it would be trivial to, for example, use this list to compute, let's say, the average price or like the standard deviation of the price for this particular asset, or add a new column that's the average price of both of the assets at that given day, or something like this. I mean, there are infinite possibilities of the things that we could do, and some of these things are somewhat trivial using Ramda. Or sorry, I shouldn't say trivial, but at least Ramda is massively expressive, right? This is really the essence of the power of functional programming. This makes it, when you start to work with Ramda, it just becomes super clear how we have to move towards functional programming, because this is amazingly powerful. It's function composition just gets us there in no time. Yes, we have to think about how to actually structure our code, but hopefully you can see how in the end we don't need tons of code. Clearly, again, granted, there are tons of ways of restructuring this in a way that makes it more dense and probably more simple. So if you have ideas about how to do that, feel absolutely free to post something in the comments and suggest potential rewrites to make this code better. I'm not at all claiming that this is super nice. And of course, let me just in the light of what we talked about before, I mentioned that we have all of these maps here, so we're sort of repeating maps. Of course, what we could do, what would be the same thing, is that we could say we could do a single map and then pipe within that map, right? So let's move actually all of these things into that and remove the first layer of mapping. So here, so I guess we'll just do, yeah, this, and then actually we can remove the parentheses here and here and here. I think we have one extra, maybe? No. Let's format that. Yeah, that looks about right? So we're piping and then we're mapping, and within that mapping, we're piping all of the stuff that needs this single mapping. So let's look at this code. Yeah, so I mean, this, as you can see, this was what we had before, and this is what we have now, so that produces the same result. And again, that's of course more efficient. Let's say, I mean, clearly now we only took 7 days from this Bitcoin data, but if you look at all time, right? Now we're looking at Ethereum. So yeah, the last date is January 28th today, but the first date let's scroll down here, right? The first date is August 7, 2015. And of course, Bitcoin is even older than that. So then we have more data. And then if we introduce more cryptocurrencies, then of course we have tons of data. And if we're actually simulating, then we might actually be interested in speed and, you know, all of this stuff. It's just unnecessary to map multiple times, unless of course you think that's more clear. And again, if performance doesn't matter. And then of course we could do the same thing here because we have a repetition of 2 maps here, right? So we could remove these 2 maps, remove the parentheses, open up here, and then r.pipe, and then 2 parentheses closing, and we'll reformat this, and that should work fine as well, right? So that gives us the same result. So then we're saying split first and then view. And I mean, depending on how you think about this, you might actually argue that this is even more clear, because then it's obvious that here we're sort of diving into the file, right? This first map is sort of on a file basis. So all of these things happen per file, right? You can think about it this way. I mean, pipe will return a single function, right? So this will become a single function that's applied to every file, which is, again, this thing, which is every path to a file, right? So it's not actually a file from the beginning. And then in some sense, maybe that's even more clear, because then it becomes obvious that, okay, we do that thing to the file, or to do every path to a file, and then when we've done that, when we've structured that exactly the way we want, then we transpose, and then we merge all the data, and then we actually log this to the screen. So yeah, maybe that's more clear. Share your opinions in the comments. Which version do you think is more clear? Now, as a last thing, I said, so I mentioned that I thought we had, yeah, okay, so that's not a problem. So I mentioned that I thought we downloaded 7 days of data, but here we actually have only 1, 2, 3, 4, 5, 6 days of data. So that kind of confused me. But if you look at the Ether data here, you can see that we have 6 lines. And if we look at the BTC data, you can see that we have 6 lines. So yeah, apparently for some reason I only downloaded 6 days of data. Yeah, that's it. That's Ramda for you. That's, of course, only scratching the surface. Again, let me know in the comments if you want to talk about lenses, or if you want me to make a specific video about lenses. I hope this helps you to get started with Ramda, and especially with functional programming. Let me know if you have any questions or comments. If you want more stuff like this, if you want more videos about programming, or if you like this video, firstly, please feel free to give this video a thumbs up, but subscribe to the channel for more programming videos. And if you're already subscribed, thank you super much for being subscribed. If you want me to do an introduction to other things, shoot something in the comments, and hopefully I can do an introduction to that. Thank you super much for watching, and I will see you in the next one.